Yes, Somasa, you can start now.
Good evening to one and all present here. We welcome all our participants at our YouTube channel. I am Soma Mondal, the lead trainer of latest technology workshop. Today, our webinar topic is microcontroller devices. We will also have the doubt clearing sessions at the end of the webinar. We welcome our guest of honor, Professor Vaishali Bagade. She has successfully completed Masters in Electronics Engineering and she is presently teaching in Alamuri Ratnamala Institute of Technology. Now, I request our professor Vaishali Bagade to carry the session further. Yes, ma'am.
Thank you, dear, for your sweet introduction. First of all, I will take this platform to wish all the best to Devendra and his group that their company, latest technology and workshop grows in leaps and bounds. And God bless you all. So the controller, switching toward the topic which I am going to deal is that Renesas RL78 family microcontroller. So the outlines which will be dealing is that, is the slide visible to you?
Yes, yes.
Yes, ma'am.
The outlining of this seminar is first we will try to understand the basic concept of what do we mean by microcontroller, the difference between microprocessor and microcontroller, how it came to existence, that is the history of microcontroller we are going to deal. Further proceeding, we will be dealing with the functions, what is the general function of microcontroller and its internal architecture along with the block diagram of microcontroller. Proceeding further, we will be dealing with types of microcontrollers and how to select a particular microcontroller. And then we will be proceeding to our main microcontroller, that is nothing but the Renesas microcontroller RL78 series family and the application of controller. Now, this is the basic block diagram, or you can say the microcontroller is an integrated chip where you do have entire computer on a single chip. This computer bridges a gap between the physical world and a computer world. It is a tiny computer that is programmable to run one program. So often we do often called as MCU, that is microcontroller unit in short, or abbreviation to microcontroller unit is nothing but MCU and MUC. Now, what is the difference between microprocessor and microcontroller? So, microprocessor consists of CPU in standalone, which does not have its RAM, that is, memory components are not present, neither it supports input-output devices, nor it has its timer control unit inbuilt in it. Basically, microprocessor has a CPU which act as a brain of any computer system. Whereas when you are talking about microcontroller, this microcontroller is a heart of embedded system. It consists of CPU, inbuilt memory, it has inbuilt input-output devices and timer units inbuilt in a single integrated chip. Now, when you are talking about memory element, since microprocessor does not have its own memory, so designer can decide on the amount of how much amount of ROM or RAM can be interfaced to it. Whereas in microcontroller, we cannot decide. It is fixed RAM size and ROM size is being developed by that manufacturer. Then the cost, microprocessor is costlier, whereas microcontroller is cheaper. Microprocessor is used for large application. They are general purpose. Hence, it consumes a lot of time and the speed is more. Whereas microcontroller is used for dedicated application. Example for microprocessor is nothing but your computer itself. Whereas for microcontroller, you got n number of devices. That is your mobile phone, from laptops. Then you got your smart TVs are there, your washing machines. These are the application of microcontroller. Moving toward the evolution of microcontroller, how it came to existence. Firstly, integrated electronics, that is Intel, has designed its first microprocessor in 1971, which was 4-bit. After that, 8085 processor was evolved, came to existence in 1974, which was 8-bit microcontroller. Moving toward that, Intel was the first manufacturing company which has designed its first microcontroller, which was 8-bit in 1976. This microcontroller 48 series had certain drawbacks, or you can say limitation, with respect to memory. Therefore, Intel 8051, which is widely used controller, which has its RAM, that is memory, is more expandable. That is, you got inbuilt RAM is more about 256, and RAM size is 256 kilobyte and ROM size is 4 kilobyte. Along with that, Atmel is a manufacturing company which came to existence in 1984, which supports the flash memory. Along with that, microchip is one of the microcontroller which produce PIC, which also produce an 8-bit controller in 1985. There are more than 200 companies which do manufacture microcontrollers. Few of them I have listed. Okay, moving toward the next slide. Now, what is the major function of microcontroller? So when you are talking about any microcontroller unit, microcontroller is a integrated chip. So it needs to be interfaced. Okay, so it has its own ports in it. So those ports can be connected to input devices. So input is an analog function which can be connected through sensors. It comes through switches. It can come to potentiometer or keypad. This input is brought into the processor where the processing carries out, and then it is displayed on the output devices. And these output devices may be your 7-segment display, it may be your motors, it may be your LCD or analog devices, or it may be your buzzer or speaker. Sometimes your microcontroller do communicate with the outer world. So the 4 functions which your microcontroller do carry is nothing but it takes the signal from input devices, analog signal, it processes those signals. After processing, it gives the output, and then it communicates with the outer world. Now, the internal architecture of any microprocessor is nothing but your microprocessor, that is nothing but your CPU, central processing unit. This CPU act as a brain of your controller. CPU consists of ALE unit, that is nothing but your arithmetic and logical unit. Along with that, it has its inbuilt registers in it and a control unit. It consists of memory elements. The memory element which it do support is nothing but your RAM, random access memory, and program memory. That is nothing but your ROM. Along with that, it supports analog to digital converters, it supports ports, it supports timers, and it has on-build oscillator which varies from 0 to 40 megahertz frequency. Therefore, the microcontrollers are used more for dedicated applications. Moving toward the next, that is nothing but your block diagram. Generalized block diagram of any microcontroller will always have a CPU unit. Then it will have a memory element inbuilt, input output devices, along with analog to digital converter. You will be having universal, synchronous, asynchronous receiver, transceiver block will be there, and timers. This is a generalized block diagram of any microcontroller. These components will be present in any of the microcontroller. Now, this microcontroller requires a supply. That supply on which, since it is an integrated chip, it works on 5-volt supply. Now, the classification of any microcontroller can be categorized into different parts, that is based on the bits. We generally call that my controller is 8-bit controller, my controller is 16-bit controller, and my controller may be 32-bit controller. So that is nothing but the word length defines what type of operation or what type of bits you are going to operate on. Then the microcontroller has the memory element in it. So depending upon whether it has an external memory required or whether memory is inbuilt. So the memory embedded in the microcontroller and the memory external to the microcontroller is also one of the type of microcontroller. Now, depending upon the instruction set, as a microcontroller unit has its own instruction set, each and every microcontroller unit, the instruction set differs more or less. Okay, so when you're talking about 8051 microcontroller, it is having its own instruction set. When you're talking about PIC microcontroller, it is having its own instruction set. In the similar manner, if you take an ARM controller, it is having its own instruction set. So depending upon the instruction set, the classification is done. Now this classification of instruction is based on RISC, that is nothing but a reduced instruction set computer, and a CIS, that is nothing but a complex instruction set computers. Now this reduced instruction set computers are having simple instructions, and they can be execute in a single cycle, and they are having less addressing modes. Whereas when you're talking about CIS, that is nothing but a complex instruction set computer, they are having lengthy instructions are more complicated, it requires more execution cycle, more than one execution cycle is required, and addressing modes are they are vast addressing modes. Taking toward the other feature of RISC is that the the transfer of data takes place from register to register, whereas for CIS it takes from memory to register or register to memory. Another type of microcontroller on which you can categorize is your Howard architecture, or you can have a Preston architecture. Preston is known as von Neumann architecture. This von Neumann architecture, as we know that each microcontroller is having inbuilt memory in it. So memory consists of ROM as well as RAM. In Preston architecture, the program memory and data memory is stored in a single chip. So the data and the codes, that is your operands and opcodes, are dumped like anything, and it has only one address bus and data bus. So what happens in Preston architecture is that the processor speed is slow, as the opcodes and operands are dumped in a single memory. Whereas when you're talking about Howard architecture, in Howard architecture, what happens is that there is separate program memory and separate data memory, due to which what happens is that it has dedicated address bus and data bus for program memory, and dedicated address bus and data bus for Preston for program memory and data memory, due to which the execution is much faster, and the the data can be easily retrieved from the memory. So this is how the microcontroller are classified in. Now, whenever you're going to choose what type of microcontroller we are supposed to choose, so depending upon what are the factors you need to consider while choosing a microcontroller. First and foremost, any person will choose what is the cost first, primary, being a person. Then what is the power requirement, how much memory we need to be interfaced, what are the internal ports, how many internal ports are available, then how many timers are inbuilt in the microcontrollers. Along with that, we should be familiar with the architecture, what type of hardware we are requiring, what type of software we require. Along with that, the simulation tools which we do require when we are choosing any microcontroller. So memory requirement, then power requirement, how much power it consumes, what are the timers, how many ports can be interfaced, is the basic aspects when you do choose any microcontroller. Now, this is the core of our seminar, that is nothing but a Renesas microcontroller, and the family which we are going to look is RL78. Okay, basically Renesas microcontroller is a controller which is a 16-bit controller. This controller supports CISC architecture and Howard architecture. It is 3-stage pipelining. It supports 3-stage pipelining. Along with that, 20-bit address bus is there, and 16-bit you got the data bus, due to which the maximum memory which can be interfaced, internal memory which can be interfaced with this controller is nothing but 2 to the power 20, which comes out to be 1048,576. That is nothing but 1 MB of memory location can be interfaced with this controller, which is inbuilt in the controller. And this family was introduced 1 decade ago. That is in 2010, this family was introduced. This RL78 family comprises of different version, that is S1 version, RL78 S1 version, RL7 that is RL72 second version and third version. All this version of microcontroller are 16-bit, and the instructions, it is having limited set of instruction which is ranging from 74 to 81 instructions. The CPU, that is your central processing unit, works on 32 kilohertz to 40 megahertz. The clock rate is nothing but 32 megahertz to 40 megahertz. Now, what are the general features? What are the general features of your microcontroller? What are the general features of your microcontroller RL78? That is, it is called as ultra low power device. It consumes ultra low power device. That is the what you can say, the input current, that current handling capacity is from 0.6 microampere. So it consumes very less current, therefore it is a low power device. Then broad, you can describe it or you can scale it on broad perspective, that is based on the pin functions. That is, it pin varies from, that is the lowest pin diagram, that is your lowest integrated chip will have 20 pin to highest will be having your 128 pins. High performance is provided by it. So depending upon the high performance, the performance based on the instruction executed by it, that is 1.39 million instruction per second is executed by the processor, by this controller. It consumes low voltage ranging from 2.2 volt to 5 volt, and it is working at a frequency which is ranging from 24 megahertz to 40 megahertz. The next is system cost reduction. Yes, the system cost reduction is very low. Why? Because everything is inbuilt in it. It got its own memory, input output device, analog to digital converters are inbuilt. So therefore the system cost, and we don't require much hardware to interface it. So therefore the system cost is reduced. Now, high performance, high efficiency in terms of the again, in terms of, you're talking about high efficiency in terms of the instruction executed by it. High quality safety is provided by it, and even the security is provided by it. That is, it supports good communication protocols. It supports good standard, what you can say, standard, you can have standard development tools are available with it, and it has a safety functions, inbuilt safety function, and security is provided by it, and it works at very high temperature. Along with that, the next feature is comprehensive development tools. That is, it supports extensive ecosystem, which, and even third party support is provided by it, and online resources are available directly. It supports the major, that is the development tools such as hardware tool and software tools are available on large platform. Now, this diagram is a roadmap. It is basically a roadmap of RL78, that is your Renesas microcontroller. Now, here, going from top to bottom, we can see that there are G1, RL78, G1 series, G110, G111, G112, G13. So it is a general purpose. This controller is used for general purpose. Then second, below to that, we got L1 series, that is L113, L112, L1C, L1A. It is for segment LCD control. Then we got the series, that is RL78, I1A, I1B, I1D. That is, it is mainly for industrial use, which is nothing but an application specific version. Now it also supports F1 series, which is dedicatedly used for automotive industries. Automotive industry even use this controllers. Looking into this picture, we have seen that this controller which was introduced 1 decade ago, that was nothing but in 2010, it has a massive production between 2017 2018. Even now there are new controllers of RL78 series has been introduced in the market for general purpose. Along with that, some under planning of this microcontroller is still going on in different applications, such as general purpose application. The under planning controller is nothing but G2X. Even in LCD and even in application specific version also, you got under planning controllers. Moving toward the next part is that this is the block diagram of your controller RL78, which consists of, as I have told you that the microcontroller is classified in different, it is classified in different architecture based on different architecture. So CISC, it do support CISC instruction set, complex instruction it supports, and it is having Harvard architecture. It do supports 3-stage pipelining. Pipelining is nothing but fetching the next instruction while executing the current instruction is nothing but the pipelining. And complex instruction set, that is the instructions are more complicated, it requires more than one cycle, but it supports that architecture to it. Along with that, Harvard architecture, as I've told you that in Harvard architecture we got separate program memory and data memory. This program memory and data memory are having their own address bus and data bus. So therefore, due to this, your controller works much faster to previous controller. Now in this block diagram we can see that there are 4 register banks. Yes, the microcontroller supports 32 general purpose registers, and each register are of 8 bits which are categorized into 4 banks. And along with that, it do supports multiplication, division, and multiply accumulate instruction also. The further blocks which consist of analog, that is analog to digital converters are there, which are 10-bit, and it has 31 channels. Along with that, communication blocks are introduced, that is serial peripheral interface, SPI, UART. You can connect it, CAN, that is control area network. Communication model consists of timer, consists of your motor control timers, it consists of watchdog timer, and it consists of timer array. Along with that, it got power management unit and a system unit which has different sectors in it. Along with that, inbuilt memory, therefore program flash memory ranges up to 256 KB, static memory is up to 20 KB it supports, and data flash is support up to 8 KB. Now the block diagram. Now here we have been specific, we have been very specific that RL78 G1 14 general purpose 14 microcontroller we are using. Okay, this microcontroller which we are seeing in detail is that it consists of different parameters, such as it has switches, it has TRIAC, FETs in it, it got audio unit, that is mic and speakers are there. Then it has Wi-Fi module which is supported by gain span module. Then you got e-ink LCD. Along with that, you got power, alt power unit, and USB connectors. The other unit which we can see is light sensor, EEPROM, temperature sensor. These are different sensors which can be connected to your controller. Along with that, peripheral module can be supported by it. It has serial input output ports, serial RS232 can be connected to it, and application header can be connected to it. So we will see, this is the anatomy of any Renesas RL78 microcontroller. RL78 microcontroller consists, the diagram which we have seen, this is how it looks on a board which has different modules. The models which we have seen, it supports Wi-Fi modules, it do supports ink segment. These are the new what you can say, components which has been added into your Renesas. So it makes it extraordinary as compared to the other controllers, that is nothing but 8051. And even if you do compare with other models such as PEC, if you do compare with ARM controllers, so it has its again span Wi-Fi module inbuilt in it and e-ink segment display. Along with that, it has a SD card slot which is provided on it. Now the vast that your controller do supports software and it do supports hardware tools. So the basic softwares and the development tools which are required for the RL78 microcontroller is that we have CS plus, that is Cube Suit, and we got E Square Studio which is based on Eclipse. We have this IDE modules. Okay, they have high performance compilers. These are high performance compiler which easily build your codes, decode your codes, and debug your codes. Okay, along with that, you got inbuilt web simulation can be available on this, which is provided by RL78 microcontroller. Along with that, you got inbuilt emulators in it, and the flash programming tool is also available. The software tool which it support is that your middleware, and along with that, it supports real-time operating system. These are the platforms on which your software modules work. Whereas if as a beginner, if you want to start with this RL78, you got a beginner kit, evaluation kit for microcontroller, which is called as a starter kit, which provides CPU boards along with the evaluation boards. Now, the application perspective of industry of this controller is that they are widely used in industrial automation. It is mainly used in communication modules. The communication modules which we have seen, motor control applications, it do supports motor control application, test and measurement, and medical appliance. These are the different sector on which your controller do provide application. Your controller provides application. So thank you. I have completed this session. I hope, are there any queries related to it?
Thank you so much, ma'am. So I will ask our participants to please ask your questions. Feel free to ask your doubts. We are here to solve your doubts. Please ask your doubts.
Yes.
एक मैम एक तो मुझे डाउट है बाय
pardon.
पर्सनल चॉइस से मुझे एक डाउट है कि मैम
Yes.
देयर आर सो मेनी टाइप ऑफ माइक्रो कंट्रोलर्स तो मैम
Yes.
हाउ वी कैन नो दैट विच आर सुटेबल फॉर अस और विच आर नॉट
That is what not. It depends upon the criteria on which you are going upon your dedicated application. What type of an application you are going to build. So depending upon that, you need to choose. If you want to have more than one timers, if take an example of 8051, it has only you got only 2 timers in it. So if you require more than 2 timers, then you need to switch over to 89C51 where you got more timers. So depending upon the applications, that is depending upon the application what you want to build, you need to choose the controller as per your needs, as per your requirements.
Okay, so we have flexibility regarding that.
Yes, you can, means you can work on, even you can work on n number of controller, but the controllers you need to choose what are your priorities. As per your priorities, as per your requirement, you can configure on any what you can say controller. And even
Hello?
the
Ma'am, you are
yes.
not audible. Okay, ma'am.
Am
Okay,
I?
okay. Yes, now you are audible, ma'am.
So depending upon your requirement, you need to choose, that is whether the software tools are easily available, whether the hardware tools are easily available. These are also the requirement, and you should be familiar with the architecture. What type of an architecture you're looking for? Depending upon that, you need to choose the microcontroller.
Okay, okay, okay. So ma'am, we are having a question around कि मैम माइक्रो कंट्रोलर के लिए पाइथन चलेगा क्या? ये क्वेश्चन पूछा राहुल वर्मा जी ने.
Micro, it depends upon the microcontroller, dear. Yes, there are languages that 8051 will not support Python language, but there are certain microcontroller which do supports Python languages. It depends upon the IDA models which are there.
Okay. और एक मैम एक मेरा एक क्वेश्चन था कि मैम इतने सारे जो माइक्रो कंट्रोलर्स होते हैं और इतने जो उसके एप्लीकेशंस होते हैं लाइक वी हैव आरटोस रियल टाइम ऑपरेटिंग सिस्टम देन आर्म
Yes,
माइक्रो
yes,
कंट्रोलर एवीआर
yes,
पीआईसी तो मैम
yes.
इन फ्यूचर को देखते हुए अगर जॉब एक्सपेक्ट्स के लिए अगर मैं देखूं तो कौन से इसका डिमांड ज्यादा है और हमें किन चीजों पे फोकस करनी चाहिए.
Yes, with the job respective, if you want to go with respect to job, then the thing is that you should know the basic of microcontroller. That is nothing but your 8051. If that concept is very clear to you, you can answer any of the questions related to any of the advanced controller because the basic architecture remains the same. Whereas there are few more addition in new controllers. Why there are advanced controllers? Because there are certain limitation in your old controllers, therefore you got advanced controllers. In the similar manner, 8051 didn't supported communication protocols. It does not support the what you can say security safety measure. It does not support, therefore this controller came to existence. So having certain what you can say limitation in the previous controller, where there is advancement in controller field, and the basic thing for any job is that you should know the basic of any microcontroller.
ओके ओके मैम देयर इज वन मोर क्वेश्चन अराउंड के वापस राहुल वर्मा जी ने पूछा है एज माइक्रो कंट्रोलर्स आर लो पावर डिवाइसेस सो
हाँ.
इज देयर एनी वे और पॉसिबिलिटी दैट वी कैन यूज हाई पावर डिवाइसेस.
The power consumption means whenever you're designing any controller device, any controller processor, the prime need is that it should consume less power. Take an example of your mobile phone. If it is working on a processor, so if it consumes more power, battery drain ho rahi hai, so that is not an aspect na. So you should have low power consumption has to be there. Your controller has to consume low power.
ओके और एक क्वेश्चन है मैम
Yes.
प्राप्ति तिवारी जी ने पूछा व्हाट इज माइक्रो कंप्यूटर.
Basically microcomputer and microcontroller have same synonyms which are being used. Microcontroller and microcomputer is nothing but an embedded system which do have your memory element, timers, everything. That is nothing but your microcomputer. That is nothing but your microcontroller itself.
एक मैम मेरा एक पर्सनल क्वेश्चन था जो हम फ्रीक्वेंसी देते वी यूज अ क्रिस्टल ऑसिलेटर.
Yes,
So
yes,
what
we do.
type of crystal do we use? I mean, I don't know about that oscillator thing. So
Yes, the most frequently used crystal oscillator we do use. Crystal oscillator we are using, which is working at a very high frequency. Most prominently, we are using crystal oscillator. There are different types of oscillator, but we do use crystal oscillator more oftenly.
I have a question. Why we use crystal oscillator? Why not other?
Because it do works in high frequency, dear.
So other oscillator not working that much high.
So that is what now crystal oscillator, because your processor are working at very high frequency, so you need to have the input what you can say the frequency which is required, high frequency, therefore it supports crystal oscillator do supports your high frequency is produced by it.
Okay, how much I cost for this development board?
For this comparative, when you're comparing with cost respective, RL78 is much costlier than your 8051. It is in 100, it is what you can say more than 500 rupees.
And what is the voltage level of a microcontroller?
See, it is a digital IC, as I've told you. Every digital IC will not have voltage beyond 5 volt. And minimum volt which is going to operate is nothing but for, it can vary from controller, that is nothing but from 2.2 volt to 5 volt. Maximum voltage won't be beyond 5 volts.
Okay.
मैम देयर इज वन मोर क्वेश्चन फ्रॉम प्राप्ति तिवारी. मैम अगर मुझे ऑटोमेशन में करियर बनाना है तो मुझे माइक्रो कंट्रोलर एंड एम्बेडेड के एडवांस में क्या करना होगा?
यस, ऑटोमेशन में करियर बनाना.
मैम मेरा भी एक डाउट है कि मैम जो भी हम जॉब लेने जाते हैं तो हमें दे आर ऑल सर्चिंग फॉर एक्सपीरियंस कैंडिडेट्स रिगार्डिंग टू embedded and microcontrollers. So ma'am, how we can improve ourselves so that we can get a nice job in basis of microcontrollers and embedded system?
See, embedded is a vast, what you can say, vast subject. So when you are talking about any embedded system, the application that is, we should be familiar with the languages, that is the debugging. You should be familiar with the software tools, how they can be utilized. User end may how you're going to utilize those tools. Okay, and how you're going to implement it. It matters more in that.
Okay, ma'am. Just we are waiting for any more questions.
Automation, regarding automation, na?
Yes, ma'am.
Automation is nothing but the yes, when you're talking about automation, so this controller that is Renesas microcontroller do supports automotive, means they are extensively used in the field of automation. Okay, industrial application is much more for this Renesas microcontroller. So you can study this microcontroller, and this is the what you can say the latest controllers which have come into in the market.
Ma'am, which language this controller support? C, C++?
Yes, it higher, all higher language it supports. All higher.
Also. Is it support Python or any?
Yes, it do supports. It do supports.
Okay. And there are two IDs, right?
Yes, C++, that is your CubeSuit, and the next one is your E square, which do support based on Eclipse.
So both are from Renesas or other developer?
They are from the partner products, okay, other
so
developers.
Which one is best for programming?
You can use it is up to you. You are familiar, you are comfortable with which IDE. It depends upon you. You're handling whether which is comfortable to you. Even in the keel part, when you're talking about 8051 also, na. So when you are familiar with keel, so you do use it promptly. If you're not familiar with C+ language or C language, you do prefer assembly language programming. So it is up to you. You are familiar with which tool.
Hello, ma'am.
Yes.
मैम व्हाट टाइप ऑफ माइक्रोकंट्रोलर इज मोस्टली यूज, मतलब अगर आर्टोस ज्यादा यूज होता है, आर्म, एवीआर और पीआईसी,
yes,
कौन सा सबसे ज्यादा यूज होता है?
सबसे ज्यादा यूज होने वाला कंट्रोलर इज नथिंग बट आर्म, the most, because nowadays every what you can say ARM Cortex 1, M1 series, M2 series, there are so many microcontrollers related to ARM. So this is nothing but an advanced RISC machine. ARM is nothing but advanced. This controller is widely used in day-to-day life applications.
तो अगर मुझे माइक्रो कंट्रोलर्स में अच्छे फील्ड में जॉब चाहिए विद हाई पेड सैलरी, सो आई हैव टू नो आर्म वेरी डीपली, है ना मैम?
Yes, ARM and the basic controller, that is 8051. If you are knowing 8051 very nicely, then you will understand ARM very easily, even for this any of the controller. But ARM is the what you can say mother of every what you can say every job, you can say means every job. For any job you should be aware of the ARM controllers. That is what I would like to suggest.
And there is one more question from Prakti Tiwari. मैम माइक्रोकंट्रोलर एंड एम्बेडेड के लिए अदर देन सी मुझे और क्या आना चाहिए? मींस आर्म, एवीआर एंड व्हाट?
ARM, AVR, what she has asked, ma'am, microcontroller embedded के लिए
अदर देन सी मुझे और क्या क्या आना चाहिए? लाइक आर्म, एवीआर एंड व्हाट एल्स?
Yes, if you are talking about the higher level languages, so you need to learn C, C+ languages. That is what it will support. Even Python it will support. Okay, but if you are talking about ARM, AVR, see, assembly languages programming is also means it is there, which varies from controller to controller. That ARM controller has its own assembly language programming. Even your AVR have its own language of programming, means instruction set. So depending upon that, you can have C is compatible with any of the controller.
Okay, ma'am. So I guess most of the questions answer have been cleared, and there are no more questions asked. Okay, so now I ask Devendra sir to declare the end of the webinar.
Okay, thank you very much. Thank you, Vaishali ma'am. It is the very great session.
Just a minute.
And,
I would like to say, Rupendra sir, very good
yes,
evening, sir. I'm glad to see you after such a long
Yes,
time.
Rupendra sir.
yes, yes.
It is a sir is a part of LTW team, ma'am.
Yes, yes.
And thank you so much for your great session. Thanks a lot.
Okay, fine. Thank you. Thank you.
Soma sir, can you give vote of
Both
thanks?
of thanks. Yes, both of
Yes,
thanks.
yes, sure.
So much.
A big thanks to Professor Vaishali Bagade for her efforts towards today's presentation. Thank you, ma'am, for sharing such wonderful and huge amount of knowledge with us. Thank you, participants, for attending the session with concentration. Stay tuned with us and our YouTube channel. Don't forget to subscribe our channel and press the bell icon. Thank you so much.
Thank you, dear. Thank you for this wonderful platform you have given to me.
Most welcome.